What is quality? There are many ways to define quality. The traditional definition is to define quality as conformance to specification. This is something we do, for example, in engineering, where we define certain measurements, and we want to make sure when we actually produce parts, they conform to those specifications, to the measurements. The measurements are actually achieved. And the more modern definition of quality is conformance to customer needs. And this is a very broad definition, right? Very comprehensive, more difficult to measure, and hence more difficult to manage also, right? But this is actually what is more desired. At the end, when you're a customer, let's say that buys a product or receives a service, what you're really concerned about is, are you satisfied with the product or the service, or not exactly about the details of all kinds of measurements. In both cases, we will say that variation is the root cause of all quality problems. It's because of variation that we have some units or some customers are not served according to the desired quality. To better understand quality, consider the following example. Suppose these are two shooting targets that you see here on the left and right, and one shooter shot 6 shots here to the left target and another shooter to the right target. So the question is, who's the better shooter? And of course, we can see that both of them are wrong somehow. If you, for example, consider percentage of being on target, if the target is actually the dark green spot here, you could say that this shooter maybe is on average better, but still there are 5 misses out of 6. Here, all are missed, but actually we can see a pattern here that this shooter actually is very accurate, but perhaps there is some kind of bias or some predictable deviation from the target, right? This is, of course, an example where the kind of mean is here off the target, right? So we have a mean that is not centered. Maybe it's the problem with the actual gun. Maybe this is the problem of the shooter that always deviates one way due to something. And here there is a different problem, right? The mean is actually quite close to the center. However, there is more spread here, right? Which is what we call variance, right? So you see that it will be important in something we will call statistical process control. We will try to control consistency, but remember that what is important in quality is not just mean, but also a variance, right? So it's not just good to be on average correct, but also to be to have small variability, like in this case, right? And because of this, we will often focus more on a distribution of some measurements rather than the one value or one simple measurement. As an example, for some quality control tools in this part of the course, we will use a certain part that is produced as that is a part of a scooter. The part is called steer support, and there are several measurements that are important, that specify what the shape of this part should be. But we will focus particularly on one measurement that you see here. So this is the part, right? You see the measurement here, and the measurement here is actually something that has to fit in this part, right, inside another part, the steering pole. And then this height here of this part here, right, this is a rotated kind of part, it has to be between 79.9 millimeters and 80.000 millimeters. So it's very important. If this part is too large, it probably will not even fit, or it will be too tight, and then maybe turning the steering will be uh, hard or impossible. And if this dimension is smaller than the desired minimum, then perhaps this part will be loose, and then maybe the scooter will be wobbly. Right here, you see a kind of tool that is used to make the part, the steer support.